Next, distance between pair of parallel straight lines. The distance between pair of parallel straight lines represented by the equation ax square plus 2hxy plus by square plus 2gx plus 2fy plus c equal to 0 is 2 into root of g square minus ac by a into a plus b, or 2 into root of f square minus bc by b into a plus b. We'll see the proof. Given the two straight lines, that is in the pair of straight lines are parallel. Pair of straight lines represents the combination of two individual straight lines, right? Consider the line equation Lx plus My plus N1 equal to 0, that is equation number 1, and Lx plus My plus N2 equal to 0, that is equation number 2. See, here we are taking two straight lines, right, whose combination is the pair of straight line represented by ax square plus 2hxy plus by square plus 2gx plus 2fy plus c equal to 0. See, note that here we are taking Lx plus My plus N1 equal to 0, constant term. Just we are changing the constant term. See, the second equation also same, Lx plus My plus N2. So the difference is only in the constant term, because they have given these two parallel lines are parallel to each other. So parallel to each other, if two straight lines are parallel, means we know only the constant term differs, right? Because a by b is equal to slope is same, no? A by b is equal to a by b for the both. That is why Lx plus My here, and the second equation also Lx plus My, right? We are taking like that. Given the equation of pair of straight lines is ax square plus 2hxy plus by square plus 2gx plus 2fy plus c equal to 0, which is the combined equation of 1 and 2. So combination of 1 and 2, that is multiplying 1 and 2, Lx plus My plus N1 plus Lx plus My plus N2 equal to ax square plus 2hxy plus by square plus 2gx plus 2fy plus c. So just we are multiplying each and every term in the left hand side. L square plus x square, m square y square plus n1 n2, L m xy plus L n2x plus L m xy plus m n2y plus L n1x plus m n1y, which is equal to ax square plus 2hxy plus by square plus 2gx plus 2fy plus c. That is Lx square plus my square plus n1 n2 plus 2lmxy, right? lmxy plus lmxy, 2lmxy. Then grouping the x term, L is common in that, so L into n1 plus n2x, and grouping the y terms. So m into n1 plus n2 into y, which is equal to ax square plus 2hxy plus by square plus 2gx plus 2fy plus c. Comparing the coefficients on both sides. So on the left hand side, x square coefficient is L square. On the right hand side, x square coefficient is a. Therefore, a is equal to L square. Similarly, y square coefficient, b is equal to m square. Then xy coefficient, 2h is equal to 2lm. Then x coefficient, 2g is equal to L into n plus n2. Similarly, y coefficients, so 2f is equal to m into n1 plus n2. Then constant term, c is equal to n1 n2. This implies a is equal to L square, that is equation number 3. b is equal to m square, that is equation number 4. h is equal to lm. 2 and 2 get cancelled, so you will get h is equal to lm, right? So that is equation number 5. And n1 plus n2, which is equal to, so we are taking that 2, because 2g is equal to, in the previous step you are having 2g is equal to L into n plus n2, n1 plus n2. Keeping n1 plus n2 one side, then taking that L on the right hand side to the left hand side, so 2g by L. So n1 plus n2 is equal to 2g by L, that is 6. Similarly, n1 plus n2 is equal to 2f by m, and that is 7, and last one c is equal to n1 n2, that is equation number 8. Now equation number 6 divided by equation number 7. So 2g by L divided by 2f by m is equal to n1 plus n2 by n1 plus n2, that is equal to 1. So 2g by L, 2 and 2 get cancelled, so mg, right, which is equal to LF, which is equal to 1. Therefore L by m, which is equal to g by f, right? We are taking m which is in the left hand side to the right hand side, it will become 1 by m, and L in the denominator on the left hand side we are taking to the right hand side, it will go to numerator on the right hand side. So L by m, which is equal to remaining term g by f, right? That is equation number 9. We know the distance between parallel lines ax plus by plus c1 equal to 0 and ax plus by plus c2 equal to 0 is formula c1 minus c2 in the modulus, right? Modulus c1 minus c2 by root of a square plus b square. Here c1 equal to n1 and c2 is equal to n2. A is equal to L, b is equal to m. So the required distance is n1 minus n2 by root of L square plus m square. So n1 minus m2, a minus b can be written as square root of a plus b whole square minus 4ab. So we are using that formula. n1 minus n2 can be written as root of n1 plus n2 whole square minus 4 n1 n2 by denominator that is root of L square plus m square. That is equation number 10. First case 1, using 6 in 10. So we are going to use equation number 6 in 10. That is n plus n2 is equal to 2g by L. That is 6th equation, right? We are substituting n1 plus n2 is equal to 2g by L in equation number 10. We will get the required distance root of 2g by L the whole square minus 4c. n1 n2 is equal to c. That is also we are going to use. That is equation number 8. So using 6 and 8 in 10, right? Minus 4c by root of L square plus m square, right? That is equal to root of 4g square by L square minus 4c by root of L square plus m square. So 4 is common in numerator, take it outside from the square root, so it will become 2 root of g square minus taking LCM, L square is the LCM, c L square by L square by root of L square plus m square. So that is equal to 2 root of g square minus c L square by L, right? We are taking L square out, 1 by L square outside the square root. 1 by L square, square root of 1 by L square is 1 by L. So 1 by L means 2 divided by L, that is there, root of g square minus c L square by L square plus m square, which is equal to 2 root of g square minus CA divided by root A into root A plus B, because we know A is equal to from 3 A is equal to L square and B is equal to m square. Using that idea, using 3 and 4, so you will get this. Therefore the required distance is 2 into g square minus CA by root of A into A plus B, right? Case 1. So next case 2, we are going to use equation number 7 in 10 and 8 also, right? So the required distance, that is we are going to put n1 plus n2 is equal to 2f by m and c is equal to n1 n2, right? So the required distance is 2f by m the whole square minus 4c by root of L square plus m square, like similar to above argument. So we are getting the same one. So 4f square by m square minus 4c by L square root of L square plus m square. So taking 2 outside, root of f square minus cm square by m square by root of L square m square. So taking 1 by m square outside, so 2 by m root of f square minus cm square by root of L square plus m square. Putting a is equal to L square and b is equal to m square, you will get 2 into root of b f square minus cb by root b into root ab. So the required distance is 2 into f square minus cb by root of b into a plus b. Thanks.